Hi everyone, are you able to hear me and see my screen clearly? Okay, so who is supposed to be muted? Okay, Frank. All right. All right. So everyone except for me, the instructor, everybody is muted. So please ask your questions using the chat. Okay, so please ask your questions using the chat. That's the best way to ask. The other advantage of asking in the chat is that you can ask your questions whenever you have instead of waiting for me to stop. All right. So, all right. So welcome to the second session, and actually formally the first formal session, because the first session that we had last week is about the introduction, which is we'll do a quick recap and then we will move ahead. All right. So, all right. Great. Just raise your hand if you are able to hear me and see the screen clearly. All right. Wonderful. Wonderful. Great. Great. So let's start our discussion. All right. So this is the general format of the session. So the sessions are generally 3 hours in duration, and we had already covered understanding big data. Then we take 10 minutes break at in the middle of the session. All the sessions will be recorded and will be available in the CloudX Lab My course. All right. So please ask your questions using the chat, and that will be easier for us. All right. So do you have any questions before we move? All right. Do you mind if I do a quick recap of what we have covered in the first session? So in the first session, we had we talked about the big data in Hadoop along with Spark. So there'll be 2 classes per week, one on Saturday, other on Sunday. Yes, yes, Fakhruddin. So the slides are going to be available to all of you. All right, I think that's more important to share with all of you. Okay, so when you go into CloudX Lab, are all of you able to log into CloudX Lab? Under my courses, when you go into courses, yes, Anaga, you have raised your hand. You can ask a question. You can ask a question by typing in the chat window. So under my courses, you will see this particular course. Okay, one is called Big Data with Hadoop and Spark. Then there'll be a Linux Basics for Big Data. The third one will be this one. All right, thank you, Anaga. Great. So, uh, so you will see this, and you will see these 2 things are more important. Okay, are you able to see these 2 in your courses? When you take cursor on your login under my courses, are you able to see this? If you're not able to see this, just raise your hand. We will take a look into it. All right. Okay, so RN is also able to see. Okay, so these are basically this one is the live instructor led sessions. As and when the sessions will keep on happening, you will get the recordings here. I'll show you like in the here. So this will contain the schedule as well as the link to the session here at the top, and more and more sessions will keep on coming as we move forward. Okay, the second one is this one. This is the self-paced course that we have recorded. Along with that, we have exercises included in this. Okay, so As you keep on finishing the exercises and as you keep on moving in the course, you should attend to it. Okay. So, so you should, all of your topics should look 100% completed. Okay. So this is where you have to pay attention. Along with that, here, if you go into, let's say, big data introduction, so there are there are these many topics under that. So since we have completed big data introduction, most of you should have attended to it. Okay. The on every topic has a resources section. Under resources section, you will see all of the slides and other resources. Also, there will be quizzes and there will be assignments here. Okay, so please attend to that. Most of it is, automated. All right. So these are basically, as we go through the course, you keep an eye here. Okay. Here you will get the studio recorded videos along with the course slide, assignments, and the assignments in the form of hands-on assessments and quizzes, both. Okay, so please keep completing this so that by the end of course you will have completed all of these. Okay, also those who want to finish early and quickly, they can go through this self-paced course, and they can keep that, then they can keep the questions ready for the session. All right, great. I hope everybody is able to see these two sections. One is big data with Hadoop and Spark. This is a self-paced course, and this is the live recordings. Most of the content is here. This one would generally have something very specific to this running course. Okay, like videos and maybe the project dates, for example. Okay, all right. So that's about the course. I'll just go over what we have discussed so far. So we talked about the data variety, structured data and structured data. Then we talked about what is a distributed system. Then we did a quick quiz around the data. So we described big data as some data that requires distributed architecture. All of the things that we will cover in this course will be distributed in nature, meaning multiple computers trying to solve a single problem. That's a distributed system. All of the components in this class are distributed in nature. Okay, they run on the cluster. Now, we talked about the characteristics of big data. We also talked about a couple of examples of various characteristics of big data. And then we understood that the bottleneck in many problems could be the rate at which you can read data from the disk. Okay, so we also talked about why data is becoming important because of devices and connectivity. And then we also talked about that in case of big data, the any of these four components become the bottleneck, and all of the components in case of CPU are important. Then we talked about the various use cases of big data. What are the advantages of big data, such as recommendations and in the e-commerce, and then A/B testing, and then government and telecom and healthcare and so on. Then we talked about various solutions, and we also described briefly what is Hadoop. Okay, so Hadoop is essentially ecosystem of products which are scalable, distributed, and reliable in nature. Okay, and these are the various components of Hadoop. One of the components that we have not talked here is Zookeeper. We will talk about it soon. So here, this is the ecosystem of Hadoop, and in this, the most important one is the file storage. That's called HDFS. Okay, then we have Yarn, which is a resource manager. So file storage is this file storage utilizes multiple computers in order to store humongous data. Okay, Yarn makes it possible to run programs on many computers, run a program on many computers simultaneously. Okay, then we talked about HBase, which is a NoSQL data storage, meaning if you want to modify records or you want to keep data in the form of records so that you can delete a record, update a record instead of a file, then you can use HBase. So HBase you can say is for structured data, and file storage, HDFS, is for unstructured data. And HBase stores its files on HDFS. Then we talked about the compute engine called MapReduce, which internally uses Yarn. And we also talked about Spark. Spark we will again talk about in a minute. Then there was SQL interface. This SQL interface makes it possible to write your logic in the form of SQL, which is internally converted into MapReduce that get executed on Yarn. And then we talked about Big Latin, which is similar to SQL interface, but just a simplified language, which we no longer cover. We will provide you the entire content for this. And there was Mahout, which is machine learning library. And there's a workflow engine called Uzi, and because in a single project there could be many things that need to be executed in the cluster. So Uzi provides us a way to create workflow. Okay, so on the similar lines we have Spark. Spark is a computing engine, meaning it does not provide any storage. It does not provide any other mm, database or NoSQL or anything. It just provides you a compute engine. What does it mean? It means that given data, you can run logic using Spark. Okay. It provides great section of libraries that we'll talk about. It is basically a replacement for Hadoop's MapReduce. So we'll focus more on Spark in this course than Hadoop's MapReduce, because most of the tasks that Hadoop MapReduce did can be easily accomplished using Spark as well. Okay. And basically, Spark runs on top of Yarn of Hadoop, meaning if your organization already have Hadoop, you don't need to install Spark explicitly. You can just start using Spark. Okay, so I'll show you that part. And Spark basically can read data from various data sources, almost all data sources available publicly. Okay, so and Spark also provides these additional libraries on top of core, because in the core you need to write programs and you need to write logic. And then on top of that, there are these libraries provided. These are called data frames. Data frames is a library on top of Spark, which makes it possible to run SQL queries on the data instead of writing logic. And there is a Spark streaming that is good for handling the continuous data, the data that is coming continuously. Most of the programs that we see in our lives are batch-wise, meaning that we run the program, it does the job, and then the program exits. But in case of streaming, the program keeps running forever. Okay, that's called streaming applications. So as and when data comes, it runs. If data is not there, it waits for the data. Then we have MLlib. MLlib is essentially machine learning library. It's basically extra functionality on top of Spark for specialized use cases of machine learning or artificial intelligence. Then we have GraphX. The GraphX is the graph computing library because many problems require the graph kind of computation, such as given a social graph, find the distance between two people. Similarly, given a map, find the path from one point to another. So those are graph related problems, and Spark provides great library for those. Then you can interact with all of these components using SQL, R, Java, Python, Scala. Even though you can do that, we will briefly cover Python in this, and we'll focus mostly on Scala. We'll also cover Scala in this course. So the course is decently big. It has quite a few topics. So be aware that you will have to work along with the course. All right. So that's pretty much about what we had talked in the first session. Any questions at this point, or should we move with our next topic? Yeah, no questions at this point? Great. So this was a quick recap of what we have done in the last session. Okay. And everything is available here in the self-paced as well as in the recording session. Okay. Recordings might take around 2 hours to appear after the session. So, okay. In that time, if you have missed the course, you can go through the self-paced part. All right. So before general before moving into the Hadoop and Spark, we generally go through a quick walkthrough through Linux and through CloudX Lab. Okay, and I think it would be a great idea if we introduce ourselves so that the whole team, because we are going to work together and study together for around 2 months from now. Okay, so it'll be a great idea to introduce yourself. And okay, so yeah, so I'm Sandeep Giri, and so all right. So I'll let you know. Wait a second. I'll just mute. I'll tell you which one to do. Okay, just give me a second. Okay, so I'll just call out the name and you can unmute yourself and introduce. So I'm Sandeep Giri. I have worked with Amazon, D Shaw, and InMobi, and most of my career has been into distributed computing and secure programming, along with building thick clients and web applications. Okay, and most the work which I did at Amazon was related to machine learning and related to the streaming, as in real-time streaming, while in case of InMobi, it was around handling 200 terabyte of data and so on. Okay, so that's about me, and Abhinav, do you want to go next? I'll just go alphabetically from top down. Abhinav is from my team, and he basically is also is working on the core areas of the big data and also machine learning with me on a couple of projects. He is also an Access student who studied in my class around 2 years ago, and yeah. So if now we have okay, Frank, you can go ahead. All right.
Hi, my name's Frank. I'm from Connecticut, and I've been in IT for about 20 years, and I'm excited about learning big data because there's a lot of problems it can solve.
All right. All right. Great to know you, Frank. I'm sure that we will learn from your experience as well.
Thank you.
All right. Yeah. Um, Anaga, you can go next.
Hello everyone, I'm Anagha. My total experience in IT is around 9+ years. So I've been mostly, working in data warehousing and in BI solutions. So working in Informatica, Oracle, some of my work involves doing, an architect role as well. So, I want to move into that uh, that space. So definitely, I think this is going to help me for moving into an architect role. Thank you.
Great, great, Anaga. Great to know you. The other reason for having, this introduction is that at the end of this course, you will have to group together in order to finish those 2 to 3 projects, and that's why it'll be great to, know each other. All right, Anil, you can go next.
Hi everyone, this is Anil, and basically I'm from New Jersey. I have been in the IT for like more than 15 years, and basically I'm from mainframe background, and I have like a very good knowledge on both the Unix and Linux, uh, doing the scripts and everything. So I have like very good sound knowledge in Python as well. That's it, Sandeep.
Okay, wonderful to know you, Anil and Frank and Anaga. And I'm looking forward to learn from you guys as well. And Anup, you can go ahead. We're not able to hear you. Anup, we are not able to hear you, so probably something is wrong.
Hello,
Yeah,
can you hear me now?
it's very feeble.
Okay, okay, okay. Is it better now? Can you hear?
Not yet. You can speak loudly. Yeah,
Okay, okay. So, hi everyone, this is Anup and I'm based out of Noida, which is near Delhi.
very. It's very very low. Yeah.
I don't know something wrong with my audio, not sure. So, yeah, basically, like I'm having almost 15 years of experience in IT and I'm mainly QA guy. I've been working in the middleware technologies like
Okay.
and all. And I'm looking forward to learn big data because in some of the projects it's being used and probably one of the customers.
All right. All right. Uh, so, all right. Great. Great. Great to know you, Anup. And Aritra, you can go next. You can unmute yourself and go ahead.
Hi, myself Aritra Bose. I'm working in the IT industry for the last 9 years, and I have been working mainly in the uh, with the Java technology, and I wanted to go into this digital technology area. So that's why I just joined this course.
Wonderful. Wonderful to know you, Aritra and Anup. Great. Great. And Saranya, could you mute yourself? Actually, there's a lot of noise coming from your side. Okay. Fakhruddin, you can go ahead. And yeah.
Hi, good afternoon, good evening. My name is Fakhruddin Mohammed. By educational background, I am electrical engineering. I've done actually my electrical engineering from IIT Kharagpur. And by profession, I've been actually working in banking, in the investment banking, particularly JP Morgan, Credit Suisse, and HSBC for last 15, 18 years. Most of my work has been in the front office arena, doing the derivative pricing and risk management systems. And by hobby, I'm into more the Internet of Things, capturing the sensor data. So I just thought, for given actually my background, it is a good to get into to get to know the big data technology more. Therefore, I decided to enroll into this course.
Wonderful, wonderful, Fakhruddin. Wonderful to know your background. And yeah, we had a, I mean, I had a similar exposure at DE Shaw onto derivatives and finance. And Gaurav, you could go ahead.
Hi, good morning. I'm Gaurav. I've been working in IT for the last 10 years. My background is basically into the SAP data warehousing side. Um, I have done educationally, I have a master's in computer science, so have some exposure to programming. But it's been a while, so trying to get back into um, big data technologies because that's where our company is headed. So looking forward to learning a lot.
Wonderful, Gaurav. Wonderful. And Kiran, you can go next. We're not able to hear you, Kiran.
Can you hear me now?
It's a little feeble. Yeah.
Okay.
You could move near to the mic.
Please. Yeah. Okay. Can you hear me better?
It's still the same.
Okay. I'm seeing my lungs, but yeah. I mean, like I said, I'm Kiran Alvi, and you heard me, right?
Yeah.
Okay. All right. Thank you.
Go ahead.
Yeah, I work for United Healthcare, and I'm a software development manager here in Kansas, and we have a big data implementation in our company as well, and trying to learn the codes to get up to date.
Wonderful. Wonderful to know you, Kiran. Looking forward to have a lot of feedback from you. Go ahead, Manoj.
Hi everyone, this is Manoj. I'm from Australia. I have 10 years experience in Teradata, Informatica, Oracle, PLC Core, Unix, and my next project is in big data. So that's why I'm learning big data and Hadoop and Spark.
Great, Manoj. Great to know about your background. I look forward to see more questions. Nitin, you can go ahead.
Hey, I'm Nitin. I'm in the San Francisco Bay Area working with Oracle. I've been in IT industry for around 15 years. So just going through this course to know about big data technologies as it is being used in a lot of new things we are trying to work in Oracle.
All right. Wonderful, Nitin. I look forward to see more questions from you. And yeah, Nitin is also my classmate from Roorkee. And next is Partha. You could go ahead.
Hey, my name is Partha Sarthi Devanathan. I'm from Kansas. I have 25 plus years of experience in IT industry. Worked on different technologies, covering Oracle and SQL, doing some of the DB activities as well, and working as a senior development manager for Optum, which is a United Healthcare company. And so we have so many implementation of big data plus other technologies. So we are trying to get into this big data and learn how to implement some of the features that we are looking forward to solve the healthcare issues.
Wonderful, Partha. I look forward to see more questions. Pawan, you could go ahead.
Hello, hey, this is Pawan, and I'm here in Washington, D.C., working Apple product development team. And
there's a lot of noise coming from your side. Yeah. Oh, actually, Manoj, I'm muting you for now. Partha, you could go ahead, please.
Hey, this is Pawan, I think.
Oh, sorry. Pawan, you could go ahead.
Around 12 years of experience, mainly Java and open source. And last 3 and 4 years, I work in enterprise search technology, different search technologies, and a couple of big data also. So I trying to learn more on big data. Thank you.
Wonderful, Pawan. I look forward to see the feedback from your side on like how can we use big data technology in the search. All right, and okay, Prashant, you could go next.
Hi everyone, I'm Prashant. I'm at Seattle location right now. So I have almost around 7 years of IT experience. I'm currently working as a SPM consultant, sales performance management consultant. I have a background in data warehousing and business intelligence, SQL. So planning for career change in big data and machine learning. That's why I entered this course.
Wow, wonderful, wonderful. Rakesh, you would go ahead.
Oh, hi. I'm Rakesh, and I'm based out of the Bay Area here in the San Francisco Bay Area. I've been in the industry for about 20 years and primarily dealing with mobile technologies around with Objective-C and Java and a bunch of cloud-based technologies like Salesforce and the Adobe Marketing Cloud. I'm recently started working with a group which deals a lot with big data, primarily with Hadoop and Cassandra. So I was actually getting myself familiarized with the technologies around it.
Wonderful, wonderful, Rakesh. And okay, RLEMAN, you could go next. I'm sorry, I'm not able to pronounce.
Yeah. Hi, my name is Ricky. I'm located here in Seattle. I'm a software engineer for the past 5 years, primarily with using PHP with a database backend. I'm trying to get into machine learning and big data architecture side of things because I'm working at one of the advertising exchange here in Seattle, and we have a lot of data that we're trying to process. So I've been trying to at least switch my career a little bit towards the machine learning, big data architecture.
Wonderful, wonderful to know you, Ricky. Saranya, you could go next.
Hi everyone, this is Sharanya. I am from Chennai. I have done masters in computer science. I'm having 7+ years of experience in this IT industry. I am working on Java. My role is technical lead. I want to take my career to the next level, so that's why I have taken up this course.
All right, great, great, Saranya, great to know you. And all right, Siva, you could go next.
Hi, can you hear me?
Yes, I can hear.
Yeah. Hi, my name is Siva, and I'm from Indiana University, and I'm a master's in health informatics student. So I'm just learning the big data course to see its implementation into healthcare, and healthcare is also turning towards big data for answers. So that's the reason. And I come from health background, and I'm not very good at IT, or I don't have very great IT experience. But I have done some SQL and R programming before.
Okay, okay, all right. Vijay, you could go next. Great to know you, Siva. You could unmute yourself and then go ahead.
Hi, this is Vijay. I have overall like 15 years of experience, 10 years working on various ETL tools, and last 5 years I've been working as a data architect. We have been implementing various warehouses and dealing with various data sources, integrating into Teradata for a while. And because of all the cost and stuff, our company wants to move towards big data. So that's the main reason why I wanted to take this course and see how I can help it take it further. So, and I don't have any knowledge in programming, but I'm a good SQL guy, and all the BI space, I'm very comfortable in the BI space.
All right, no worries. You will learn it with us. And great to know you, Vijay, and everyone. And I'm very humbled by the audience we have. It's I assure you that I'll be able to do justice to the course. And feel free to speak out in case you are uncomfortable with any topic. You have any questions, feel free to ask. These sessions are known for getting your questions answered, because the content of these things is kind of open source and it's all over, but what we provide is a structure to the entire thing. Along with that, the clear explanations, hands-on lab along with the answers to the questions. So the objective of this class is to get you up and running with the entire big data stack. All right. Thereby, there could be slightly extensions based on, say, there's a new technology. Let's say data frame is now getting more traction and it has become stable. So we'll expand the data frame part of Spark and we'll decrease the dose of other part. So these sessions are more for getting your questions answered and getting into the flow. All right. So I'll try my best to do justice to the course and all right, so keep your questions coming. I'm going to take you really fast through the Linux introduction because what I understood from the discussion was most of us are good with Linux, and we'll do a hands-on with the CloudX Lab, and that's why that's where you will further you can actually do the entire hands-on using our Linux tutorial, which is provided for free to you. Okay, I'm just going to give a very brief and quick overview of Linux one. All right, so it's a quick introduction to Linux. So Linux runs on many devices, the mobiles, the cars, and the fridge, and even the watches, the smartwatches. And these are the various components of a Linux program, Linux operating system. So these are the various components. The first one is the programs. That's the highest level. And when we run anything, it's a program. Okay. Then there is a kernel. Kernel is the main part of the operating system, which talks to the hardware. The shell is the interactive prompt that is given to you via which you can run program and interact with the kernel. Okay, so shell is a program that interacts with kernel, and it's a flexible program which can execute other programs. Okay, in Linux system, everything probably is file. Almost everything is represented as file, and this group of files is called Linux file system. The whole Linux file system, as opposed to Windows file system, has a single root. In Windows, you have C colon, D colon, and E colon, right? Here, there is only one at the top level. It's called slash, under which everything is mounted. Okay. Generally, we have TMP at the top level. So slash is the top level directory in which everything is there. And in the top level directory, we have TMP. This is where programs create their temporary folders. Then we have home folder. In this, the home of all the users are available. And then in etc, most of the programs keep their configurations. Okay, inside home, there is a directory for every user. So there are two users here. One is Sandeep, other is John. And inside Sandeep, here, all the files are modifiable by Sandeep. Here, all the files inside John will be modifiable and owned by John. All right. So you can connect to the Linux console right away using the web console. How do you do that? Click on My Lab and go to lab credentials. Click on web console. You can also use PuTTY from Windows, or you can use SSH from Windows. Okay, since we have many users, so we have distributed the users on many hosts. For me, my web console is on e.cloudxlab. This is where I'll be copy pasting my username. We have provided a button to copy paste so that it becomes really easy. Then we take the password and copy paste the password. In Unix, when you type the password, nothing appears, as opposed to Windows where asterisks appear. Here nothing appears. So now I have been able to log in. Okay, so here if I say pwd, this is my home directory. This is slash has home folder, and this is my home directory. Okay, so it'll be great if all of you also log in with me. Okay, please type on the chat if you are done with logging into the console. Okay, if anybody is stuck, I'll just take a quick look and then we can try to fix it, or one of my teammate can help you fix the problem. Okay, Kiran is done. Siva is done. Great. Manoj is done. If you're stuck, just let me know. What I'll do is I'll present your screen to everyone so that if anybody is also struggling with the same issue, they will be able to solve it. Okay. A question from Ricky. What is the IP address again for SSH connection? For me, it is e.cloudxlab. For you, it could be F or G or H, okay, or E. So when I click on Web Console here under my lab, then this opens. This is your Web Console. Okay, same thing you can use. You can also, I'll show you. Let's say this is my host, right? So we have divided users amongst multiple hosts because there are quite a few users. So instead of Web Console, I can also use SSH. So instead of, I'll remove the HTTP colon and last slash from it. And my login is this, right? I'll say Sandeep Giri 9034 at this. Okay. It'll prompt me for the password. The password is same. Okay. All right. It is not prompting because I've already set the password. Okay, question from Fakhruddin is my console is not allowing me to paste the user password. Do I have to change any properties of console? So you are using web console only? If you're using, if you have Chrome, then please use Chrome. That is most compatible with most of our services. Are you using Windows or you are using Linux or Mac? Okay, so you can use Apple C and Apple B. Okay, I see. I'm not sure if Safari would allow me. Let me just check if it does. Okay, maybe the Safari does not allowing copy paste. Yeah. So if you're not able to copy paste, you can click on show password and just type it. Okay. Okay. No, the password is different. Password is different. This is login, while password is something different. You can click on show password to see the password, or you can just press copy button here to copy the password. You can, a question from Vijay is where can I find login credentials? You could go to My Lab. After logging into CloudX Lab, you could go to My Lab and then click on lab credentials. Okay. So Pawan, you could message Abhinav privately your email ID, and then we can take a look at your account right away. Great, Frank. Or you can just privately message the panelist. You can just message me privately. I can take a look at it quickly. Okay. All right, wonderful. So most of you are able to log in. Pavan, you can message me privately, your email ID. I can take a look at it. Okay. All right. Is anybody else facing the problem? No worries. One of us will take a look. Yes. So the home directory would be empty by default. A question from Anil is, how can I paste the Linux command with mouse click? Are you using Windows or Linux? Pavan, I have been able to successfully log in into your account. I just tested it. Do you want me to take a look at your screen right away? Okay, and all right. Again, so what we are trying to do is we basically, after logging in into CloudX Lab, we went to My Lab. Okay, we went to My Lab. Under Lab Credentials, that is the second tab, we went to the Web Console and copy pasted the login and password to log in into the Web Console. Okay, that's what we are trying to accomplish. So these are only the beginning time where it takes a bit of time, but rest of it will become smooth if this gets done properly. Okay, so all right, so please raise your hand if you're stuck. Pavan, do you want me to take a look at the screen? All right. So it's just the beginning couple of minutes that take a bit of time for everyone to get on the same page. And afterwards, it becomes very smooth because the main thing with the technology is that the bootstrap time. Afterwards, once you get up and running, you will be able to do a better job than the rest. Okay. All right. So for Purnima also it says login incorrect. So did you use the copy paste button? I see. I see. So Pavan, you could try again. I was able to log in and yeah, try again. Your console is on e.cloudxlab. Okay. All right. All right. Purnima, we'll take a look at your account. Okay. No worries. So after the session, I'll take a look at the account. Okay. Okay. So, all right. So, okay. Please raise your hand if you're stuck and somebody would help you quickly from our side. All right. Question from Vijay. These credentials are till the end of course. They will be 3 months from the beginning of course, which is last Saturday. Last Sunday actually, not Saturday. Okay, so great. Purnima is able to log in. I think Pavan, did you try again? Yeah, I was able to log in using Google Chrome. All right, wonderful, wonderful. Okay, so please raise your hand if you are stuck and not able to log in into Web Console. Click on the Web Console, key in the password and log in. And how do you reach to this screen? Click on My Lab, go to Credentials. Okay, click on My Lab at the top, on CloudX Lab, and then click on Lab Credentials and click on Web Console. Okay. Everyone? Wonderful, wonderful. So I think everybody is in. So this is my terminal. I'll just make it a little smaller. Okay. So when I say PWD, it is showing me my current working directory. When I say ls, it's showing me my files. Since I've created a lot of files, okay, already, so for you, it'll be empty. All right. Okay. So Pavan, you could try with maybe Chrome or maybe SSH. That should help you. Okay. The login passwords are correct. I've tested it in the Chrome. Okay. All right. The other thing, what happens is while copying the password here, what happens is sometimes we copy the space also. Okay. So like, for example, here we are copying this, not this. Say, while copying this way, we generally copy. Okay, now there is no space. I see. I see. Okay, so should we proceed? Is everybody able to log in? When Pavan is not able to log in yet. Anybody else is not able to log in? Okay. All right. Maybe we can try it during the break. Yes, Beatrice. Go ahead and use the chat in order to ask question. All right, Beatrice, and great, great. So also to like the way we are connected to the console, if you want to copy the file directly to the console, we can install any FTP client. Okay, such as WinSCP or 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 say FileZilla, and that you will be able to transfer files from your laptop to this Linux console. Okay. All right. So further, I'm just going a little faster on this. So to learn more, learn Linux in more detail, you can go through this tutorial, which has been provided as part of course here somewhere. You could go to say tracks, or you could go to just my course here, my courses, and here start the course. And this is the one using which you can actually learn in more details. Okay, so all right, we will talk about HDFS commands a while later. Right now we'll skip this part. Okay, so this is not really required at this point. So we are able to log into the web console. You can check your username, what's your username or what's your ID using who am I. Okay, and basically everything is a file in the Unix, and some of the files can run as a program. The user executes the files, they become programs. And for example, Angry Bird that you play on your mobile is a program, example of program which you can connect to, that gets executed on the kernel. When a program is launched, it creates processes, and program or process will be used interchangeably. Okay, the program and process will keep on using interchangeably during the course. And the core of Linux, handles main work of operating systems, such as allocating time and memory to the programs, handling file system, responding to various calls to various hardware devices. Okay, and so the user interacts with kernel via shell, and the console, as opened on the previous slide, is the shell. So this is the shell. Okay, this is the shell. Here where we are typing, it's called REPL, read, execute, and read, REPL, read, execute, and process loop. Okay, and here you can keep on typing the commands, and it'll keep on giving you the output. Okay, so ls displays the file listing, cd changes the directory, the PSSWD changes your password, but don't change your password, please. And file command displays the type of the file. This would be new to you. So there is a command called file. It checks the inside of any file and tells you what is there. Let's say, for example, I have this file in my home folder. It says that it's a ASCII text. Okay. Similar, if I say this one and I say file, it says that it's a zip archive data. All right. Similarly, if I say this one and I say file, it says it's a bash script. Great. So using file command, you can see what's there inside a file. To see the content of a file, you can use cat command. Okay, I'm hoping that you are able to log into web console. You can use SSH from your desktop. Okay, and yes, on Linux system, everything is a file. If something is not a file, it is a process. A Linux system makes no difference between a file and a directory, since a directory is just a file containing names of other files. Programs, services, text, images, and so forth, all are files. Input and output devices, and generally all devices, are considered to be files. Okay. That's it. So that's pretty much about Linux. So I'm hoping that that's clear to everyone. All right. So the homework assignment is to finish this one. This will kind of refresh your knowledge about Linux. Some of you are, really good with Linux in this session, so they can skip if they want to. All right. All right. So that was a kind of quick overview of the basics of various technologies. All right. So the first entry point for the course is the Zookeeper. Okay, the Zookeeper. Should we start? Just raise your hand. That will be good enough. Is everybody with me? Should we start? Wonderful, wonderful. Great. So let's quickly start our journey to the Hadoop ecosystem. And out of all of these, the most important component is Zookeeper, though we have not talked about it in that architectural diagram. Okay, because Zookeeper is a general component, just like Linux. It's a general component used by many other components the mm, as the main coordination engine. Okay, for example, it's not Hadoop alone which uses Zookeeper. It's also Kafka and other systems. Even Cassandra uses Zookeeper, Spark uses Zookeeper, and so on. Okay, so Zookeeper is this kind of the common denominator of all the technologies. Even though none of the certifications include Zookeepers, none of the big data certifications include Zookeeper as the knowledge, but we realize that it's very critical to learn this particular component. Okay, as we learn Zookeeper, you will learn a couple of more things about distributed systems, such as Paxos algorithm, such as election mechanism used by many other systems like MongoDB and others. So when we learn Zookeeper, we learn these other aspects. So the idea is to understand the distributed computing in details. All right, great. So let's get started. Now, before jumping into Zookeeper, there are some basic things. So what do you understand by a race condition? Anybody? What do we mean by a race condition? In the computer science, you must have heard about this term called race conditions. Anybody? Go ahead. Correct, correct. So yes, when two programs are going after the same resource or competing resource at the same time, it gets stuck. All right. So race condition is not same as the deadlock, Aritra. You will see that probably you are talking about deadlock that we'll come to in the next slide. Okay. So a race condition is this. It's a simple example. Imagine there is a bank and person A and person B. Okay, they both have they duplicated their ATM card. Okay, and they both are trying to transact at the same time, exactly at the same time. So or there are two ATMs just adjacent to each other, and they have inserted ATM card in both, logged in parallelly on both the ATMs, and both are withdrawing money, or let's say both are depositing money. Okay, here it's depositing, sorry. So let's say there's person A and person B is in this diagram, and they are depositing $1. They had $17 in their account. They're depositing one more. So what would happen is, let's say person A and person B both added one, both had 17, and they added one, and they became 18. And now if person A and person B both write to it at the same time, the end result will be 18 instead of being 19. Right? Do you see this? This is because of, at the same time, as Fakhruddin says, that the two processes are competing at the same time for the same resource. So 18 basically is a corrupted data. As per it's an inconsistency caused by race condition. Okay, instead of 19. So this is called race condition. Is it clear to everyone? Ideally, the answer should have been 19, but because of the bug in the system, they both end up writing 18. Yes. All right. This is called race condition. These both transactions are happening on the same account of $17. Okay, same person's account, but two processes are trying to modify this account detail from different places. All right. Now, question to all is, what is a deadlock? Yes. Feel free to answer quickly so that you all stay awake and you can work with me. Hearing theory is little too difficult, and we feel sleepy, so it's better to answer. Okay, so what is a deadlock? Anybody? All right. So what Aritra has answered, that's correct. When OS gets stuck due to some cyclic repair, or any program or any set of programs get stuck. Thank you, Rakesh, Ricky, and Frank, and Purnima, and Fakhruddin, and Ricky. Wonderful, great. So this is a good example. In both the diagrams, what you see is this car is waiting for this car is waiting for this car is waiting for this car, and back, this car is waiting for this car. This is deadlock. Okay, similarly, there are three processes, process 1, 2, and 3. They are waiting for each other. These look like impossible circumstances, but truth is that we all end up doing deadlock. In the product that I built in a company called TBITS Global, in one of my startups, there we ended up doing the deadlock, and that happened in production. Okay, so no matter how much we think that we can avoid deadlock, we end up doing deadlock at a lot of places. Okay, so deadlock is deadlock as well as race conditions. Both are really hard problems to solve in engineering. Okay, specifically computer engineering. So in deadlock, say for example, let's say there is a query, SQL query, which is executing and modifying the table, and that table is waiting for another execute query, which is further depending back. That's how a deadlock is caused in case of databases. Similar thing is true in case of processes, and it's very common to have a deadlock. All right. So these are two important concepts to know about before going ahead with Zookeeper. All right. Another question to all of you is the coordination. Okay. Let's say that we have email processors which are reading emails at the same time. Let's say there is the inbox which contains email 1, 2, 3. And there are these email processors. You can imagine email processors, maybe they are you can think of them as they're indexing the inbox. Processing could be that somebody is marking the email as spam, not spam, or it could be that processing email to extract keywords from it so that it can index it, so that it can be searched, and so on. Imagine that there are multiple email processors, right? And they want to coordinate. They want to coordinate such that no two email processors, no two email processors get no two email processors process the same email, meaning no email get processed twice, as well as no email should be skipped. What kind of architecture would you suggest? Let's say the inbox is largely read only, okay, but each email has got an identifier, and this inbox is read only for you, and you have been running these processors on multiple machines. So there are email processors that are running on multiple machines and trying to read data from this inbox. Okay, now these email processors need to coordinate so that they do not process the same email twice. Also, none of the email should get missed. What kind of architecture would you suggest? So this, as of now, there is no queuing here, Ricky, because the email processors are parallelly connected to the inbox. Okay, they all get the view of the inbox. They are connected via, say, POP3. The important part is that every email has got an identifier. Yes, please go ahead. Had they all been running in the same memory space, they could have created locks, right? Point from Rakesh is create groups and hand it to the processor. Okay, okay, that's a good idea. All right. Anything else? But for grouping, you will need a central agent which will first read the inbox and then hand it over to multiple processors. A point from Pavan, should we have some persistent space, DB, where status of each email is shared? That's right. Okay, so Frank's point is you can use algorithm to decide which processor gets which email. But if we do that, let's say we have processor 0, okay? What processor 0 does is that's the only one talking to the inbox. And then that's the one who is asking various processors to do the processing. That's kind of a master-slave model, which Frank and Rakesh is suggesting. And in that kind of model, what happens is the one who is interacting with the inbox would be responsible for dividing the work. Okay. But if that goes down, then the problem occurs. Maintain processed email identifier in some placeholder, and all of the processors should check first before processing. Point from Ricky, can the inbox has a flag for each email? Good, good. Right, great set of answers. So the first answer could be that there is a master processor which reads, I'm just reiterating your answers. Okay. The second suggestion was that can we create some kind of flag on emails? Okay. Let me say that you can only have two flags: processed and not yet processed. There is no flag for processing, right? You can mark every email as read or unread, okay? But there is no flag for being processed. The problem will arrive in case, let's say there is a processor 1. It started processing email 1 and then died. Okay. So the other email processors will basically not able to touch that. All right. So unless we have 3 states, we won't be able to go with that model, Ricky. All right. But when you can write to everyone, your answer is right. So yes, in these kind of circumstances, these couple of models, what you have suggested are the ways which we actually do it. One is having a master-slave model. Second is maintaining the state with every email, as in every marking the record as in various state. The third is maintaining a database, central storage, right? So what we learned was, in case we implement our own processor, there is a risk involved, right? Second one, where we are labeling each email. There we will have to have that flexibility on inbox. That we are not getting. So the right way is to have a central storage as the coordination. So whichever email is being processed, which is under processing, is kept in the central storage. And once that is done, email is marked as read, finished. Okay. So whatever is being done right now, we keep it in a central storage. So this is the data that is being processed. So the logic in email processor is that go to the inbox, pick up, say, 10 emails which are unread, then go to the central storage and keep checking which of these emails are being processed. If it's not being processed, then write its name that I am processing it so that others don't process it, and then start processing. So it's like let's say there is a sales team having multiple people, and they're given a list of people to call. Okay. And this list is not divided. There's a huge list, and this list keeps on coming all the time. So there's no way to divide it. So what they decided, they write on a whiteboard saying that I am processing this, I'm calling this person, I'm talking to this person is my lead. So they write their name on the whiteboard that I am handling this client, so that others come to know that somebody is handling it, and so on. So that's how these email processors are handling emails. They write on the whiteboard that I am processing it so that others don't. This is exactly where Zookeeper comes into place. This storage that you see this side, this tiny storage, right? Tiny, why I'm calling it tiny? Because it'll just keep 3 IDs, because 3 emails will be continuously processed parallelly, right? So it'll contain only 3 IDs. Therefore, this is exactly the use case of Zookeeper. Zookeeper provides you this central storage for very small data for coordination. All right. So it's a distributed coordination service for distribution applications. Okay. Do these words make sense to you? So this is a distributed service. Email is being processed parallelly. Same logic is running at 3 places, processing different IDs. So the system is distributed. Now this central storage, okay, this central storage has to be really robust. It needs to internally run on multiple computers. And that's what Zookeeper provides. The Zookeeper itself runs on many computers. Therefore, we call it distributed. A question from Ricky is, what happens if Zookeeper encounters failure, such as hard disk failure? Exactly. So this is why there are many Zookeepers. There is no single Zookeeper. All right. This is some architecture. That's what we are going to learn. All right. Good. Keep these questions coming, and that's the only way we are going to work it out. All right. So Zookeeper exposes a simple set of primitives. What does it mean by primitives? Primitives as in very basic operations. Okay, basic operations such as get and set. All right, and it's very easy to program to. You can write program for it easily. Okay, and it uses a data model like directory tree. Okay, it uses a data model like directory tree. Question from Partha is, does yarn coordinates with zookeeper to get status? Yes, yarn keeps on tracking. The yarn uses zookeeper in case of high availability architectures. Okay, similarly, um, even HBase, even HDFS uses zookeeper. Kafka uses zookeeper, and even the I think Cassandra, some of the Cassandra models actually work with zookeeper pretty well. Okay, so zookeeper provides the simple set of functions so that people can use zookeeper to coordinate instead of implementing their own coordination service, right? We always end up thinking that, okay, we'll have to create a centralized processor which will distribute the work as you were suggesting. That's what is general temptation, but implementing such a service is really hard. Therefore, zookeeper does a very decent job for coordination. Okay, I'll talk about it. All right, Rakesh, yes, I'm going to talk about that part very soon. And the objective is to make you understand how does a real distributed application behaves. Okay, so the last point is it uses a data model like directory tree. Okay, meaning you can interact with zookeeper as if you are interacting with normal Linux file system. Okay, one way is just keep the data in the key value. Here it provides the hierarchy in the key values, okay, in the form of a directory tree. We will interact with it and you will get the more clarity. Okay, so it is used for synchronization, locking, and maintaining configuration. All right, Pavan, are you with me? It is used for synchronization, locking, and maintaining configuration. Okay, so many other programs, let's say you have written a service that needs to synchronize with other services, they can use zookeeper, this small central storage, to talk to. And then locking, it can lock. Let's say you're building a service which needs to lock certain data the way we wanted to lock emails so that others do not process it. In that case, we can use zookeeper. Similarly, maintaining configuration. Let's say your website is running on 30 machines parallelly in the production, and it continuously need to read the latest data, latest configuration. In that case, it can use zookeeper for maintaining configuration. Also, failover management, we will talk about it. Let's say there are 50 servers and they need to be discovered by the client. These 50 servers can write their name to zookeeper and they can make themselves visible to the clients via zookeeper. Okay, coordinated service can this is a great zookeeper is a great coordination service which does not suffer from race conditions and deadlocks. Okay, so any system which has many users in parallel, they end up having race conditions and deadlock, and zookeeper does a great job at avoiding these two things. Okay, so Suprashant, here we go. So you can think of data model like a really highly available file system, and every node is called a Z node. Okay, like the way we have file system, there is files and there is directory. Here, there is something called Z node. Z node means like a file or folder. It's a tree structure. Okay, the data that you keep in G node is in the form of JSON data, like setter getter. So you can set data to every Z node, and you can set some value. There is no append operations provided on the data. All right, and data access is atomic, either completely safe or don't safe. Right? Then Gnode can have children. Okay, Gnode form a hierarchical namespace, just like there are folders. Folders can contain folders and further folders. Okay, here there is no files, only folders. Just that every folder can also keep some data in the form of JSON. That's what we call Znode here. So let's say there is a root one slash. There we could create a Znode slash Jew. Then under that we could create duck, goat, cow, and so on. All right. The first one is persistent Znode. Second is ephemeral. Why I'm rushing? Because I want to do hands-on first before talking about this. Okay. Now we are going to create the persistent Znode. All right. Is everybody ready? So before jumping into data model, before explaining, okay, I'm going to log in into the console. Sorry. All right. And let me open this. Yes. Okay. Let's interact with Zookeeper first before jumping into theory. Okay. You can understand better after doing a little hands-on with Zookeeper client. Okay. So I'm going to start Zookeeper client. All right. Just a second. Just give me a second. Okay, so let me just check what's up with Zookeepers. Let me just try checking it. It has been a while since we used Zookeeper. It's nice. It's actually fine. Is it working with the F? Yeah, it's working now. Great. So if you type Zookeeper client, you can try. Let me just copy paste the command to you. Okay. Now it should be working fine. Okay, so this is how we interact with Zookeeper. Zookeeper also provide an ls command to take a look at the node. In ls, we can say specify which Z node are we trying to create. You can see there are quite a few Z node already created. Okay, so we can also say help here to take a look at the what are the various commands available. So we can take a look at statistics using stat. We can set data of something. We can take a look at ls. We can also take a look at say history, and yeah, we can also delete a path, we delete a folder, or we can use create. Okay, let's try to understand the create part. Okay, let's start there. So I'm going to create a Z node for this class. Okay, inside top level directory called slash. And what should we call this class? Let's call this class as 6 August. Okay, and here's some data. Let's say I've just put in 1 2 3 4. Anything that's a valid JSON data is needed here. Okay, so I've created a 6th August folder here, as in 6 August G node. Okay, using this, you don't have to do this. Now, under this, I can put another Z node under 6 August. 6 August is under slash, and I've created a Z node called this. Okay, this is the data that would be sitting on this. Okay, so a Z node, this is called a Z node. A Z node can have some data, and Z node can have another Z node inside it. Okay, all right, let me again type 6 August, and I'm saying my login 9034. This is so that it becomes easier to identify, and I'm just saying my data, or I'll just put some array just for the heck of it. Okay, all right, so I have created two Z node. One is 6th August and other is Sandeep Giri 9034 inside 6 August. So please create your own Z nodes under 6 August. Okay, and it'll be easy for me to monitor. Okay, all right, so I can always take a look at who is able to create so far. So far, Purnima is able to create other than me. All right, and we can take a look at the data. The data is same as what I've kept. Okay, in case of, let's say, in case of Sandeep Giri, inside it, it has some data as a JSON array. And okay, I hope everybody is acquainted with JSON. Okay, so far, all right. So I can see when I say press tab, it auto completes. So we have Ricky, Pavan, Nitin, Purnima, Partha, Rakesh. Everybody has created. Okay, JSON is JavaScript object notation. Okay, JavaScript object notation. I'll just give a quick 1 minute overview of JSON and then we'll take a break. Okay, so a JSON, when you are representing something, when you represent, or I can just do sketch. I'll take a break after this. Okay. Okay, so you could, when defining a data could be an array, data could be a number. So JSON is a great format to define a data structure. So let's say you want to say a number, you'll just say some number without anything. If you're saying a string, it'll be double quotes and string. Okay, if you want to say array, you will say array like this, and right. So this array contains two values. One is a string and other is this. Okay, then you can create objects in JavaScript notations in this format. You could say key values. Okay, key values here. This is a name. Okay, so Just like XML, we had a data format. Here we have, okay, and let's say age. So we can define any complex structure using JSON formatted data, okay? Or we can say, let's say likes, okay. We can create an array here, tag, movies, and so on, right? So we are able to define, the complex structures of data using JSON. All right. We could create comma, colon separated, but then there'll be a need of parsing it manually. So JSON provides all these parsers to convert this into objects very easily in almost every programming language. One programming language or one system, when they want to talk to another system, or one user wants to transfer their structure to somewhere, it is better to use JSON and other similar formats. Okay, I hope that makes sense to you, Sanjaya. Okay, so two systems, when they generally talk in today's time, they use one of the formats like JSON in order to convey the structure of data. Okay, so is everybody able to create? So please create the okay. The command to see the Z nodes is ls/6august. All right. Here we are trying to see the, right? Or you could just say get or ls and press tab. It'll autocomplete. Okay, so these many users have been done. Yes, Anil. So we are creating G nodes under 6 August. Okay, you don't have to create. Okay, so whatever you create, it will be reflected at a central storage. It's a central agency where the data is going. Okay, so you have to create under this. Okay, the way I have created for myself. Similarly, you could create for yourself. So Partha, you have to remove the trailing slash. Okay. This command was wrong. This was not completed. I was just pressing tabs. Okay. All right. It says node exists. So you could also see this. Using ls, you can take a look at what all has been created. Wonderful. Wonderful. So yes, everybody's able to do it. Great. Let's take a break for 10 minutes. Back by somebody can post in EST. I'm posting in IST. All right, so I'm back. Should we start now? Okay, Fakhruddin is back, Kiran is back. Who else is back? Please raise your hand and that should be good. Great, great. So let's start. Let me check. This one I don't have to ask. I can quickly check who all have created their Z nodes. Wonderful, wonderful. So the way I created was this. You could also create in the similar way. So Pavan has done, Nitin, Anagha, Partha, Ricky, Aritra, Rakesh, PJ, Purnima, Vijay. All right. So this way we can create G node. If I have to create one other node inside this, I can do slash and say X. Okay, I can create further under here some other G node so that when I say ls slash 6 August and they say Sandeep, Giri, and you can see that there are two Z nodes under my name. Okay, now everybody gets it, like what kind of folder structure or what kind of structure does Z node have. So this is the path or the name, the fully qualified name of the Z node, and this is the data that's lying in it. Okay, so I can say set this data to something else, and I could say this time say 1, 2, 3, 4, and so this time I have just set the data of this Z node to this one. Okay, if I want to see what's there inside it, I can say get and the URL. Okay, so you can see the data inside it, and these are the attributes of this Z node. We'll talk about these. Okay, so we learned few things. One is ls. ls lists ls lists the Z nodes inside a particular Z node structure. Create creates the Z node with the given parent name and the parent name along with the given data. Okay. Then we talked about set sets the data for each Z node. So Z node has a path, Z node has a name, Z node has the data stored there. Okay. Then to see the data inside a Z node, we can use get. Great. All right, wonderful. So the way you just created your Z node here, in the similar fashion, the various other applications have been using it. For example, if you take a look at here, okay, if let's say you take a look at inside brokers, okay, the brokers, okay, so ls slash brokers, right? It says there are IDs. Okay, I say IDs and there are these IDs. Okay, and I say get. Okay, so what you see here is that these are the brokers. Okay, these are the IP addresses of brokers of Kafka. So Kafka is maintaining the information about various Kafka brokers inside Zookeeper. Okay, Kafka is a queue. Kafka is a software that runs on multiple machines in order to provide you uh, a enterprise bus or a message queue in an organization. Okay, so Kafka, HBase, HDFS, everybody uses Zookeeper. And how do they use? They create their own Z nodes and keep data in those Z nodes, the way you and I just did. Okay, in the same way, the software just instead of talking through this command, they use the API provided by Zookeeper. Make sense to you? Great. Okay, there was a question from somebody, I think Ricky, that will I be teaching the installation? We won't go into too much detail about installation. Instead, we will understand the overall architecture. Okay. For installation, if you want to do an installation like what we have done at CloudWorks Lab, you can straight away use Ambari from Hortonworks, and it will do the magic of installing everything for you. If you have multiple machines and you have hardware resources, then you can get everything done in a single shot using Hortonworks Ambari. Okay. So now does this diagram make sense to you? This diagram showing this structure. All right. Most of the systems, whether it's Znode in Zookeeper or whether it's files in HDFS, which we learned later, or the folder structures in Windows or Unix, they all follow the tree model. Folder inside folder, and so on. Okay. In Windows, the slash is inverted. In here, the slash is forward slash. I think this is called backward slash. I don't know. Okay. And all right. So we created Znode so far, and the Znode that we created by default are persistent. There are three kinds of Znode that we can create: is persistent, ephemeral, and sequential. Okay. A question from Pavan. This is important as of now. Question is, each tool have own installation, or we need to point it to point the same? So we need to tell each tool generally that the Zookeeper is running at localhost 2181. Okay, that's how we generally inform the tools. And most of these tools actually understand that the Zookeeper runs at a port 2181. All right. So there are three kinds of Znodes: persistent, ephemeral, and sequential. Let's understand those. Persistent ones remain in Zookeeper until deleted. The Znodes that we have created will remain the same even when you come next week. Okay. Until somebody from admin team or somebody deletes those Znodes, they will remain there. So we created Znode using create / some data and providing my data. The second kind of Znode is ephemeral Znode. Okay, ephemeral Znode. These Znodes are very interesting. They get deleted by Znode as soon as the session ends or times out. So if I create Znode and I exit the Zookeeper client, the Znode will disappear if it is ephemeral. Okay, the ephemeral Znode disappear or get deleted automatically if the client who created those disappears. Okay, so this is very similar to what happens in case of web session. In case of web session, if the client does not access the site for some time, it generally expires. Okay, in some cases it keeps the session for years, but for some cases it expires immediately. Okay, so if ephemeral nodes are deleted by Zookeeper as soon as the session ends. Okay, though these Z nodes are tied to client session, but these are visible to everyone, meaning they remain in existence temporarily, but they are visible to everyone. Ephemeral nodes are not allowed to have the Z nodes inside those, meaning they cannot have children Z node. Okay, because if ephemeral Z node goes down, as in disappears, the children will also disappear. That could cause mistakes on user's perspective. So from the use case side, ephemeral node cannot have children. So the way you do is you create the Z node exactly the way we created earlier. Just you put dash E in between create and the path. Okay, so you do create dash E, and so they cannot have any kind of children, neither ephemeral nor normal. Okay, yes, they are only one node deep. All right, so I'm going to create a parent Z node. Okay, I'll talk about sequential Z node later. Let me try to create. Let me just try to say 6 August EPH. Okay, sorry, not like this. I need to give some data as well. This time it is created, and I'll show you. So I'm creating a Z node inside 6 August EPH, right? And I put some data. So this has created my, sorry, this is wrong. I should have created with dash E, and let me give it some other name. Okay, so you can see that the this particular node, okay, and okay, so this is an ephemeral node. Let me show you what does it mean. Generally, in ephemeral node, there is an ephemeral owner. Okay, so if I do get on this previous Z node that I created, the ephemeral the ephemeral owner then is 0. Okay, so this is how you can check if a Z node is ephemeral or not. All right, so I'm going. Let me take a look at 6 August EPH. Right, so we can see that the Sandeep was a normal Z node, while Sandeep Giri was ephemeral one. If I exit at this point, okay, right now I just exited from Zookeeper client. Okay, and let me see if I go back after a while, what would happen? Will this Z node disappear or not? Can somebody check? Has it disappeared? I've exited the client. You can check with ls/6 August EPH. Okay, it'll take around 4 to 5 seconds. Did it disappear? Yes. So that's what it means. Now, if I, so this must not, that must not be there inside 6 August EPH. Okay, so what you see is that ephemeral nodes kind of maintain the head count. The way we have participants list here, in case of Zoom, it shows the name of everybody who is actually logged in right now. And the moment if your network connection goes down, after a while, the participant list will remove your name, right? And so that's a functionality provided by Zookeeper as well. This functionality can be utilized by many other applications. Okay, there are many use cases of such functionality. It's kind of attendance maintenance system. Let's say you are trying to maintain how many clients are active right now. So what you'll do is in the client code, you will basically write a logic that it informs Zookeeper by the way of creating ephemeral nodes. Okay, and that's how it is. All right, does it make sense to you now? So this is called ephemeral node. Okay, it's a very simplistic data structure that you talk to a central system, create a Z node, either persistent or ephemeral. Ephemeral will disappear as soon as your session is gone, you got disconnected or something happened. Okay. Now, the next one is sequential Z-node. Okay, sequential Z-node. In this kind of Z-node, there is a very good utility. It creates a node with a running sequence count. Okay, it creates the node with a sequence number in the name. All right, so the number is automatically appended. Inside a particular Z node, the number starts from 0 and keeps on going up to few million. Okay, so you keep on creating Z node inside a Z node, and the number will keep on going. If you are creating a fresh other parent, then again the number will start from 0. Okay, let me show you what do I mean. Okay, so I can create sequential Z node using dash s, and I'm saying here APH, and I'm saying SG and putting some data. Okay, so you can see that it has created a Z node with a running count of 6. Why 6? Because probably 6 Z nodes were created. Okay, as and when more and more Z nodes keep on creating, this number keeps on increasing. Okay, it automatically appends that number to the name, meaning every Z node maintains its children count, and when you are calling create, when you're calling create with the dash s, it appends that running count to the name. Okay, are you able to create your sequential node in the 6 August EPH? Wonderful, wonderful. Some of you have been successfully able to create. Okay, so if here the running count is say 13, and if I create, let's say I pick Sandeep here, and inside Sandeep I create another sequential number. Okay, so I say Sandeep, and inside that I create my first ephemeral, not sequential node. Okay, so you can see that the number starts from 0. Why? Because it is created inside Sandeep, which is inside 6 August EPH. Make sense to you? Now, question is, what's the use case? There was a use case of ephemeral Z node, right? But what's the use case of a sequential Z node, right? So let me explain to you. Sequential Z node can be used for creating the ID generation system. Let's say you are having a help desk. Help desk system, and in help desk system, you generally need to create an identifier for every request that's coming from the user. So help desk systems generally create some ticket number, request number, or request ID or ticket ID, right? And there is a need of creating a next number, and that next number generation becomes impossible if there is a lot of concurrency required. Okay, if there are hundreds of requests coming in per second, you would need to use some system like Zookeeper. Okay, do I make sense here? Yes, sequential Z node remains there until deleted, just like persistent. Some more examples of sequential. Okay, let's say you are building, how should I say, you're building any system which requires a unique and running count. Let's say a document management system where you need a running count of versions or running count of something. Okay. In those cases, you can make a call to Zookeeper, create a sequential Z node. It will generate the number, take that number, delete the sequential node, and that's it. Okay. So you can create and delete, but the number will keep on monotonically increasing. Okay. Good, good, Nitin. You were just on the time. All right. And yes, I kind of thought that that will be one question. Great, great. So yes, so we can create and delete the Z nodes, or if we want, if we can also maintain certain small data. All right. Although the deletion could be lazy, it could be like periodic. You could delete these Z nodes after 10 minutes or 1 hour, and doesn't matter. Okay. So this was a quick interaction with Zookeeper. The max number is, I think, the 32-bit integer. Okay. That's the max number for the Z node counts, as per my understanding, or I think it's 64-bit integer. I'll have to take a look at it. So these many digits, what you see here, these many digits. Okay, very good question. And all right, let's start with the architecture of the sequential of the Zookeeper. All right, so the architecture is there are two modes of Zookeeper. One is called standalone. When you set up Zookeeper, one is that you install it on one machine and then use it, and that's of no use. There's no practical use of it. If that's your use case, you want it only on one machine, you better use any existing RDBMS. Okay, but and standalone mode is generally used for testing because it does not have a high availability. Okay, the second is replicated. The architecture of Zookeeper is replicated, meaning you run Zookeepers on a cluster of machines. You have like 10 machines or 20 machines. You install Zookeeper on all those machines and run it. This cluster of machines on which Zookeeper has been installed is called ensemble. Ensemble, and in ensemble, these machines discover each other and they use Paxos algorithm to do an election. It has a high availability and it tolerates as long as majority of machines are up. Okay, so I'll just give you a very simple example. So the Paxos algorithm dictates how do many machines work together without a master slave architecture. Okay, master slave architecture is we designate a particular machine to be master and rest are slaves, and then we try to keep the load on the master as low as possible so that that one doesn't die, and pray that it doesn't die, the master. But in case of a truly distributed system, nobody is a master. Nobody is a master. Everybody is equivalent and they choose a master temporarily and so on. This mechanism lies under Paxos algorithm. There's a person named Paxos who works, I think, at Microsoft, and he gave the way wrote a very detailed paper on coordination. Okay, a question from Ricky. It's on the right time. Are most of the nodes data resides on the memory on each zookeeper server? Yes. All of the data that you created, the Z nodes that you created, is kept in the memory of every machine. You will understand it as we go ahead. Okay, so let me explain what happens. So the way you set up Zookeeper is you install Zookeeper server on all the machines. Okay, and inform all the machines about all other machines. Okay, by the way of providing a list of configuration. So we created, say, 3 machines here. All 3 knows each other. They will ping to each other, and then they will ping to each other, and they will try to figure out who can be the leader. This mechanism is called leader election. The machine which is having the most latest data, the machine which is having the most latest data, you saw the monotonously increasing number, right? The machine that has the highest number, that one is generally considered the leader, meaning that has the most recent data. Okay, so Zookeeper maintains the state by the way of increasing number, and using that number, when they elect somebody, the election is based on who has the most recent data. So machine came into the network, they started pinging to each other, and then they decided on a leader. One of the one who got elected is called a leader, and rest become followers, right? And this phase is finished when most of these systems called followers have synchronized themselves. They created the Z node, they pulled the new set of data from the central and brought themselves up. This is called synchronization. So this phase is the phase of election finishes when all the followers got the latest data from the leader. If the leader fails, the remaining machines, let's say the leader fails, remaining machines will hold the election again, and the one having the best, most recent data will become the leader. Okay? And this election happens in around 200 milliseconds. If the majority is not available at any point, the leader will step down. What does it mean by majority? Majority means more than 50%. 2 out of 3 is majority, 3 out of 5 is majority, okay? 2 out of 3 is majority, 3 out of 4, 3 out of 5 is majority, okay? More than 50% is called majority. At any point of time, in case there are lesser than or equal to 50% node, then the leader steps down. The leader steps down and there is no election if there are no majority. If there is no majority, there's no election. Okay, so the whole zookeeper will become read-only if there is no election. Okay, because everybody will be a follower, and follower does not accept changes. Follower can give the data but cannot make changes. All right, so ensemble holds election, selects a leader, and there are followers. Followers only give the data, they only provide the reads, but the writes are forwarded to the leader. Leader, the single entity, takes the writes. Why? So that there is no conflict. Okay? There's no inconsistency. In case there are multiple systems taking the modification request, there will be inconsistency. Okay? If there's a request from client to the leader to make modification, after a while, once the modification is done, okay, so client sends a request to the leader for modification. The leader informs all of the followers to save the data. after it has saved the data. So leader will broadcast to all the followers that there has been a modification request, please save it. So when you said create znode, this is what you did. You were the client, you wrote to the leader internally. Internally, your request was routed to the leader, the request for creating a znode. And this leader informed all the followers about the modifications. And as soon as 50%, more than 50% informed back to the leader saying, yes, we are done with saving the data. Yes, we are done with saving the data. That's pretty much. Okay. So as soon as the majority saves the data, that's enough. As soon as that happens, then client gets a confirmation that write was successful. So when the majority of the machines have persisted the new data, only then client gets a successful message. Okay. All right. That also brings us to the point that in case majority goes down, then there will be the system will become read only. Why? Because write can never be successful. Okay. A question from Rakesh, and if any machine come on board, they will remain a follower even though they have a higher number until a leader. No, if a new machine comes and that one is having more recent data than the leader, then the leader would step down, the other one will become the leader. Okay. And that would ideally not happen often, because if since the data is broadcasted to all the followers and majority is saving the data at any point, if the one who is having the latest data is not available, the chances are the whole cluster majority is not available. Okay, that the probability of that happening is really, really low. Okay. A question from Kiran: what happens to the follower that did not respond back to the leader? Will it get synced? Yes, it's still syncing up. It's just taking a little bit more time, maybe a millisecond more. Okay, is the election clear to everyone? Yeah. Okay. The protocol for achieving consensus is atomic, like two-phase commit. Consensus meaning when we want to write something, that one is atomic. Okay, so machines write to the disk before in memory. Also, a copy of the whole data is maintained in the memory. All right. Now, yes, Ricky, it can be done on multiple EC2 instances easily. You just have to download the Zookeeper server on all of the instance and create a list of Zookeeper node, create a file containing the IP addresses of all, open 2181 port to each other and let them interact. Okay. So that's how it can be done on EC2 instances. Good. Now here's a question for you. Question to all of you. So we talked about election. Election is that all the machines come in the network, they vote for a leader, and the leader is the one who accepts write requests and broadcasts the data to all of other machines. And this is how Zookeeper maintains the replication, as well as this is how Zookeeper maintains the replication of data as well as high availability of data, along with strong eventual consistency. Okay, why we call it eventual? Because let's go back here. the follower has not got the recent data, and user has come and asked follower this third one for new data. The follower might give an older data. Please keep in mind that sometimes one of the followers could give an older data, or some of the followers could give older data, slightly older. Therefore, the data in Zookeeper is not consistent. It is eventually consistent. It is eventually consistent. All right. Okay, here is a question to you. If you have three nodes A, B, and C, with A as leader and A dies, will someone become leader? Is 2 by 3 majority? Is 2 out of 3 majority? So one node has died and 2 are still available. 2 is more than half of 3, right? Half of 3 is 1.5 and 2 is more than 1.5. Therefore, somebody will become the leader. So A has died. So either C or B will become the leader. All right? Either C or B will become the leader. Right? So, okay, let me clarify Ricky's question. So when A died, there are two nodes, right? So majority means more than half, more than 50% should be available. So 2 out of 3 is still a majority. Therefore, there will be election and one of the two nodes will become the leader. So if A dies, it doesn't go out of the cluster. All the nodes, they still have A in their list. Yes, they still have A in the list, right? If you want to reboot the cluster, you'll have to delete A from everybody's list and then reboot. Then the cluster will have only two elements. Right now, A had just shut down. It's not responding to pings, and it's not participating in election, but it is marked as member of the ensemble. Okay. Okay. A question is, so generally only when the leader dies or if there is a better leader, then the election happens. Those two circumstances, Aritra. And it takes around 200 milliseconds to take the election, to do the election. Good. Now, a question is, let's say we had A, B, and C, C being the leader. Okay, you have a cluster with three machines, A, B, and C, running Zookeeper. A and B died. Will C remain the leader? A and B have died. Will C remain the leader? C will step down. You are right. C will step down. No one will be the leader as majority is not available. Because 1 out of 3 is not majority. 2 out of 3 is majority, 3 out of 3 is majority, but 1 out of 3 is lesser than 1.5, therefore it's not majority. The cluster would become the read-only. A question that arises very commonly, that it's a very frequent question, and this question you will also face from time to time, that if we have, let's say, 6 nodes, A, B, C, D, E, F, and out of this, only 3 have died, we still have 3 servers running, right? We still have 3 servers running. Why does the cluster become read-only? Why it goes useless? We still have 3 machines out of 6 machines. Imagine we had 60 machines, 30 have died, 30 are still available. Why this? Why is this need of majority? Why do we need majority? Okay. Anybody? Any answers? Why do we need majority as such for election? Why do we need to have, imagine that you have a cluster of 100 nodes and 50 are still available and the cluster has become read-only. There is no majority. Do you think this behavior to be odd? Any answers? All right. Let me. Yes, you're right, Anil. It's for high availability, but why exactly? Okay. Give me a little more details, please. All right. Let me continue. Any questions at this point, or you have answers? It's a very important question, and generally when people come to me and then they say that they have designed a distributed system, I generally ask them that why does this happen? And yeah, even in the case of MongoDB, if you have heard about a database called MongoDB, it's the same scenario. And so, okay. In their each replica set, it's the same mechanism what we see here. Okay. Similar is the case with a couple of more databases, distributed databases. All right, that's correct, Pavan. That's correct. And I'm going to demonstrate what does it mean. Great, great. All right. Now, imagine that you have your cluster in 2 data centers, data center 1 and data center 2. Data center 1 is having A, B, C, and data center 2 is having D, E, F. Okay, these 6 servers are part of your ensemble of Zookeeper. All right, and imagine that the wire that was connecting 2 data centers is cut. The wire got disconnected, the network got disconnected, and these 2 data centers are like 2 separate disconnected islands. Okay, so imagine what would have happened if there was no need of majority to become a leader. What would happen is B and C would vote for A, so A will become leader in data center 1, and E and F and D will form the leader as D. Okay, so you got 2 leaders, A and D. Both of the leaders, A and D, are accepting the modifications. Imagine somebody deleted the Z node in A and the other one updated the same Z node in D. Okay, so there'll be a utter chaos, there'll be a confusion. As Pavan says, it will be kind of a split brain thing that one is modifying, other is deleting, someone is appending, and other one is resetting the data. So the whole consistency will go for a toss. The two leaders, two set of servers from data center 1 and data center 2 will become irreconcilable. We will not be able to reconcile their data, and they will diverge in their own dimensions. Therefore, there is a need of majority. Okay, how does majority help in this? Here, three could vote themselves and so on. Majority helps in this way that there can be only one majority. No matter how you divide these six people, there can be only one group of people who is majority. There cannot be two majorities. There cannot be two partitions of a cake. If you cut a cake, no matter how you cut a cake, there cannot be two partitions of a cake where one both of them are greater than 50%. Whether you cut a cake into 10 parts or 20 parts, there can be only one part which is bigger than 50%. Right? Therefore, will be only one election, and hence the majority helps keeping a single election, single leader. Do I make sense to you? No? Okay, this was a very important phenomena, and this is a common question when people go for, let's say, tomorrow you are going for a discussion on MongoDB or any other similar CouchDB or similar database where the same Paxos algorithm is used. Okay, so I've taken a very extremely simplistic example, and this example generally explains the need of majority. Okay, similar is the need of majority while persisting data. While persisting data, if majority of the machines are persisting it, okay, so in case majority is not available for election, there won't be any election, and hence the nodes that are available for election, they will have the latest data. Okay. Yes, this happens to any clustered environment. Okay, quick question to all. If you are sleepy, just wake up. An ensemble of 10 nodes can tolerate a shutdown of how many nodes? An ensemble of 10 nodes can tolerate the shutdown of how many nodes? Wonderful. Yes, it can tolerate only 4. Sanjaya, so if 5 are shut down, so what will happen is 5 out of 5 out of 10 is not majority, it's just half. It should be one more than half. Okay, it should be one more than half. Okay, so now this was a core idea behind Zookeeper. So Zookeeper has this distributed architecture, as well as it helps distributed services to coordinate and so on. So a client has list of server in the ensemble. It tries each until successful. Server creates a new session for the client. A session has timeout period decided by the caller. Okay, let me detail it a little bit. Okay, so the client, as in when you use Zookeeper Desk client, you were using the client. Each client maintains its list of servers in ensemble. It keeps discovering and keep on maintaining this list. While booting the client, you can explicitly also provide the list of servers. So it will basically try all the servers in the ensemble until it's successful. Now, as soon as it is successful, it will be, if it's trying to modify, then it will be redirected to somebody who is a master, okay, so who is a leader. The server creates a new session for the client. Okay, server keeps in record that there is a user, there is a client which has come online. It creates a big number representing a session. The session has a timeout period. The session has a timeout period, meaning the session will get deleted if the client does not ping to the server, does not inform that I'm alive. If the server has not received a request within the time period, it may expire the session, and on the expiry of the session, ephemeral nodes will be deleted. Okay, ephemeral nodes created in that session which is being expired, all the ephemeral nodes will be deleted. To keep sessions alive, your Zookeeper Desk client, that program, kept on sending the pings to the server. It kept on sending the pings to the server, and we call those pings as heartbeat. It is continuously saying with a delta, with a around 100 milliseconds or so, it is informing the server that, hey, I am alive, I am still up, it's running. Okay, so don't delete my session, keep it available. So client library takes care of these heartbeats. The client library provided by Zookeeper takes care of all these heartbeats and entire mechanics of redirecting from follower to the mass leader or and so on. Okay, so sessions are still valid while switching to another server. Say your Zookeeper Desk client was connected to a particular Zookeeper server, and after a while that server went down. It will shift to another server, but session will not be deleted. Session will be available because it's not client's fault. It is the server's fault. Okay. The failover is handled automatically by the client. The failover is handled automatically by the client library or the client. Okay. Application, but having said that, even though the API under the hood, the Zookeeper's library, that API that is provided to you, is taking care of the switching between the multiple machines, moving to different server and so on, but your program, which is using that library, cannot remain agnostic to the server connections, because sometimes you are trying to write and you could be in the middle of the failure of the server. Okay, so your operations could fail, so therefore you need to keep retries and other things. Okay, now let's talk about the use cases of the Zookeeper. Okay, imagine that you have many servers which are giving certain service to many users, and on the other side you have many clients. So you have many servers providing the same website or web service, and you have many clients. You have millions of clients and hundreds of servers. Now these clients cannot keep pinging to all of your servers all the time. They cannot keep tracking which server is done, which server is dead, and which server is available, right? So in these kind of circumstances, you keep Zookeeper. Okay, you keep Zookeeper. All right. So if some server, so you keep Zookeeper, and how does it happen? As all the servers come online, they keep on creating ephemeral znode, and those ephemeral znode keep on disappearing as servers go down. So every ephemeral znode contains the IP address of the server. Okay, so when the client comes to Zookeeper and says, give me the list of servers, it'll give you only those znodes which are still active, those machines which are still active. All right, imagine this. Imagine this, that let's say there was a server called duck and there was a server called cow. They came to the Zookeeper and created an ephemeral node under a znode called servers. Here it has created under servers it has created duck. This one has created cow. Okay, let's say the client came and said, give me the list of servers. Okay, what will it give? It'll give duck and cow, right? Right. Both of these ones are ephemeral Z nodes. Now imagine after a while, this first one has gone down, right? Then when you say ls servers, what would happen? It'll get only the cow, because if the first machine went down, this duck will disappear. This Z node will disappear, and therefore will not be given to the client. Do I make sense to you? So this is a use case of ephemeral Z node. Instead of client keeps on pinging to all machines, or if there are m clients and there are n servers, so m into n, these many permutations of trial will happen. All the clients trying all the servers and checking if they're up or not. Instead of that, all the servers just keep informing Znode that we are up, and Zookeeper maintains this registry of Z nodes representing each server, okay, which are active. The kind of guarantees Zookeeper provides is sequential consistency, eventual and sequential consistency. Okay, update from a particular client are applied in order. Okay, atomicity, all the changes either succeed or fail. There is no midway. System single image, a client will see the same view of the system. The new server will not accept a connection until it has caught up. Once an update has succeeded, it will persist and will not be undone, because one, it keeps the data in the disk. Second, it keeps it persists to the majority before confirming to the client. Also, if let's say there is a cluster which is going read-only for very long time, okay, very long time, it will shut down. The read-only servers will shut down instead of catering the old data. There are many operations. Okay, a question from Sanjaya. Sanjaya, please explain the single system image again. Okay. Okay, good point, Nitin. All right, a very good question, and from Sanjana as well, Nitin. Let me explain that. So, question from Sanjana is that what is single system image again? Okay, so the client will see the same view of the system. Okay, and if there is a new machine that has been added to the cluster, it will not accept the connection until it has at least once caught up with the master, with the leader. Okay, at least once it should catch up with the leader. Okay, and single view as in whether the client is connected to A, B, or C, the client will generally see the same data. Okay, that is what it means by single system image. Nitin, did it make sense to you? Okay, let me reiterate what do I mean. So let's say there is a new machine which has been added. That machine will not accept connection until it has caught up. Okay, So here what it means is that let's say there is a machine which is already a part of cluster and is older. So yes, system could give a little older data, but if, okay, all right, let me take a step back and yes. So as I said that the system provides the eventual consistency, not the not the strong consistency. And so until, right, okay, let me read your question. If there are A, B, and C, right, and update completes in A and B, it will commit and C will be old for that. Yes. So in that case, the data it will have is older data. Okay. So in those cases, there could be an older data, and yeah. All right. Although here it does imply, okay, it does imply that until the system has caught up, it won't give the older data. So yeah, I think there is a disconnect here. And because as per my understanding, it is eventual consistency. So here the single system image is something that we need to understand clearly. Single system image would be probably from the perspective of a particular client, that let's say it was accessing data from a particular node, and it was at certain number. The max number of the system was at certain number. Now, if it shifts to another machine, at least that much number should be there on that machine. Okay, number as in because the whole system's state is maintained by a eternally increasing number. Okay, so if there is a client and it was reading from some system and it is moved to another system, so the another system should be at least of that number, at least of that state where it was in the previous one. That's where it is. That's what it's trying to say. A client will see the same view of system, whether it's connected to A, B, or C. All right. So probably the client will not be shifted to another machine which is not up to the mark. All right, let me just, yeah. Okay, so what I understand is, other than the eventual consistency, let me explain. Let's say A, B, and C. Okay, all of these are, let's say, at a certain number. This one is at 100 number. 100 number means the state the way it defines is by increasing ID. Okay, and C is little older. Let's say C is 99, correct? And this was the user from here. User was connected to this one. Okay, user was connected to this one. So the client is seeing the state as 100. 100 is the state. Now, if this one goes down, the client will not shift to this one or this one. Client will not shift to this one. Client will shift to this one. That's what it means by single system image. Okay. So at least that much number should be there. But if there is a new client, let's say some client CC is coming, they can talk to C. This is what I understand by single system image for a particular user. Yes, CC gets a little older data. Okay. All right. Let me read one more question from Partha. If the commit is not complete in C, the client request will be shifted to A or B. Commit is not complete in C. Okay. Commit as in yeah. So yeah, commit was not complete in C, therefore it was little behind, as in by one number. And if there is a read request, it can definitely cater to the read request. Okay, maybe I'll have to look at it again. All right. Though this one, this statement, what I'm talking here, does imply that the new server could not, yeah, it won't cater, but I don't think so. This is only applicable for a particular client. A particular client. Let's say that you are seeing a particular node at a certain level. You won't be shifted to another node which is having a lesser older data than yours. Okay. Do I make sense or am I lost? Nitin? You can unmute yourself if you want to. I'm talking to Nitin because yes, Rakesh, go ahead by asking question.
Could you then talk a little bit about timeliness? Who decides on how long you have to stay up with stale data before you will shut down? Is that configurable, or is that a different way to get to that conclusion?
Okay, okay, no worries. So let me explain. So this timeliness is configurable, and you can configure it while setting up your Zookeeper cluster. All right. Okay. You can yeah.
Hey, sorry, Sandeep, I had issue with my mic. So, I mean, I'm still confused. Like the request, any client who is attached to C, right? The data which is in being processed may not get the exact value. Then the system could not be designed for synchronization and other things. Maybe the data which is being coming to C, I mean, it is somehow recorded that it is in process and C does not give that request for read or something like that happens, because something has to be there. Otherwise, how will we use for synchronization, or that part is not really clear to me.
Okay, okay, okay. So here the question is that if it is catering the older data, that then it will cause the inconsistency issues, right? And
Correct.
therefore we cannot use it for synchronization. All right. So the idea that Zookeeper has come up with, that they basically say that from a user's perspective, from a client's perspective, their data, when a client is interacting with something, then um, the the individual client will actually see the same state, but some of the clients would end up seeing the older data. Okay, so this should be kind of informed to all the people, and this is something
No,
which is a part of design. So
no. How will then we will design the first use case you mentioned about the email system, right? So therein, how will I know that somebody's processing or not? I will get old information. I may not come to know, okay, that guy is processing. I may start processing, right?
right. So
And I
the
may
general
overwrite also, because set when I do, I think it just overwrite. It does not say that it is already written, or there is no way to check during set that
no,
if
so
data is
the
set, don't set it. Only
cool,
set it if it is not there. Something.
cool. Let me explain. So how will I do? I think yes, I got your question, and yes, okay, very good question, and let me try to explain it. This is a very good time to do it. So let's say there is a processor P1, processor P2, and processor P3, right? And all of them are talking to Zookeeper. And how do they coordinate? They coordinate by creating Znode. Okay, creating, let's say we call it email processes, and here it just creates the email ID. Okay, so what each of them do is they try to create this Znode. Okay.
Okay. Or just to, will creation fail, you are trying to say? I'm trying.
Yes,
Okay,
yes.
got it. Now I got it. I mean, maybe you can
Okay,
explain for others.
okay. Great, great. So what will happen is, let's say email, I'm calling the number 1234. Okay. So 1234, 1234. Okay. So the moment the first one tries to do this, it'll fail, right? So, or let me try it
So
other way.
basically, they will not use get to check. I have to pick. They
Uh,
will
so
just do a create, and if it succeeds, they will proceed. Otherwise, they will give up. Right?
the other
I
way
guess.
could actually you can also do get. I'll explain. Okay. So you can have fun logic ls, right? So let's say there is a list of unread emails minus the list of which are existing here. Okay, let me do that. So list of unread email IDs minus list which is being processed right now, and then for remaining one, for each in this list from here to here. For this list, you will try creating. Okay. And the moment you are successful, you will start processing.
Cool, cool. Got it. I missed that
Okay.
point.
Okay. So very good question. Very good question. So let me explain. Okay. Anybody else? Great. Wonderful questions. All right. So what we discussed just now is that if this system is giving inconsistent results, how we can use such kind of system for synchronization, specifically with respect to the first example that we took. So the general strategy would be that we know that the system is inconsistent, as in system is eventually consistent, not right away. That's why instead of just subtracting it and picking the first one out of it, what you do is you subtract the list of available unread email IDs by the one that is being processed, and iterate over each one. If you are able to create, if this create was successful, then only start processing. Okay. All right. Did I make sense to you? All right, great question. Everyone, am I making sense? Here I've just written some pseudo code. Okay. A question from Partha: does single system image is specific to client or session based? Does single system image is specific to client or system based? It's based on the client, the user. A user should see the same data or a little updated data. It should not see an older data. As the client is shifting between multiple machines. Okay. And of course, it will be the same logic everywhere. The same logic everywhere. Do I make sense, or should I explain again? Should we move ahead? Wonderful questions. Okay. We will continue from here, from the guarantees in the next session. Okay, we are already beyond time by 6 minutes. All right. And those who are having difficulties with respect to getting started, feel free to drop us an email. We will take a look at it, what exactly is the problem, and then if needed, we will send you an email with a schedule so that we can have one-on-one. Okay, so feel free. If you are in a bigger doubt, we will schedule a one-on-one with you so that we can help you out with getting started. Okay, so stay tuned and see you tomorrow. All right, so finish going through these chapters here in the in the in the learning management system. Make all of these 100%. Okay, just finish the exercises, make it happen. Okay, some of these exercises will make you do things. For example, if you go into Linux one, it'll ask you to log in into the system at least once. Okay, so this one will make you go ahead only if you have at least logged in into the system at least once. Since I have already logged in once, it is letting me go. Okay, great. So we have designed a system so that we all can work without need of evaluation all the time. Okay, I look forward to see you. Okay, no worries, Purnima. I'll try to upload the recordings as soon as possible if you're traveling. Okay, so no worries. And in the meantime, you can actually go through the pre-recorded sessions, these recordings which we did in the production environment, as in the recording studio. They are far more clear and less noisy. So you'll be able to attend to those. Okay, great. All right, see you tomorrow. I look forward to have wonderful set of questions again tomorrow. Bye-bye. Have a good day.